Welcome to the channel Professor Davinci. We are in the topic series and a sequence. Last video we have seen the formula for sum of series. We have seen the formula sum of series. That is say like this 1 plus 2 plus 3 plus dot 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 until say 50 or 60 whatever number. So we have seen the formula. The formula is say Sn, sum of n terms. Okay, it is half times n into n plus 1. We have seen already. This is a 1, right? We have seen. Now here the last term, what is the n? N is the last term. N is the last term, right? This formula is used. This formula is used when we have the first term is 1. So this is valid. This formula is valid for the series starts from 1. Say you can say 1 plus 2 plus until 40, or 1 plus 2 plus until say 400, 1 plus 2 plus 3 plus until 1 million. So this sum of series, this formula, the above formula, half times of n into n plus 1 is valid if the first term is 1. Okay, right? Then for example, if we have say for example, if we have 5 plus 6 plus 7 plus 8, for example, let us take the fourth term. So now the series does not starts from 1. Here what to do? What to do? Okay, the above formula will not work. Let us check. Say check the above formula. Check. Okay, what is the above formula? Sn equals half times of what is the n? N is number of terms. How many terms we have? 1, 2, 3, 4 terms, and plus 4 plus into multiply by is n into n plus 1, right? So n into n plus 1, which equals say 5 into 4 20, 20 by 2 equals 10. This is the answer. But if we count 5 plus 6 plus 7 plus 8, which equals to 26. Okay, so it is very much evident that if the first term is not 1, the formula Sn, this 1 by 2 n into n plus 1 does not work. So in this case, what to do? So we need to derive a new formula based on the Sn. What is the previous formula what we have? So we say for example, say we need to derive a new formula which is not starting from 1. Okay, for example, we take this one. How can I write this one? 5 plus 5 plus 1, that is 6, right? Then for 7, 5 plus 2 into 1, that is the difference. So already what we know that say 1 plus 2 plus 3 means what we can say. So this is 1 plus the difference, first difference. What is the difference between 1 and 2 is 1, and then 1 plus 2 times of difference. Okay, so this we have seen already. Same thing applies here. Same thing. So the difference between the two term is 1. So the first term is 5, second term is the 1 term of the difference, second term is see what is the difference between 5 and 7? 2, that is 2 terms of the difference between each term. And then 8 will be 5 plus 3 times of the difference, right? What is the 3 times the difference? 3 into 1. Okay, right, 3 times of the difference. Clear? So in general we can say, generalize this one. In general, we can say sum of series Sn equal, the first term is a and the second term is a plus what is it? Okay, a plus the first difference, one times of a difference, and a plus 2 times of the difference, and dash 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 dash. What will be the last term? We don't know the last term, so just we can say last term minus 2 times of difference plus last term minus the difference plus last term. This you know, right? This you can listen, but how I derive this one? For example, is it says a 5 plus 6 plus 7 plus 8. 8 is the last term. Okay, 8 is the last term. This is L. What is 7? So last term minus 1 time. So what is the difference between 7 and 8? It is 1. So L plus minus 1. And what is the 6? L minus 2 times of difference, right? That is 2 times of 1. So what is the difference between 6 and 8? So 6 and difference is 2. That means 2 times of difference. You see here, from the first term, how we are adding the difference in terms: 1 time difference, 2 time difference, and 3 time difference. And from the last term, with respect to last term, the previous term will be last term minus 1 time the difference. The previous term is last term minus 2 times of the difference. Clear? So this is how we got this above equation. Okay, right? So I hope you have understood this one now. So here, if we add the corresponding terms, will be equal to a plus L. If we add the corresponding terms, it will yield the sum will be equal to a plus L. How this one? Say, let us say, erase this one. Let us see. Sorry. Just say we have 5 plus 6 plus 7 plus 8. I think corresponding. What is A? A is 5. What's L? Last term is 8. The total A plus L equals 5 plus 8 is 13, right? So the corresponding term means add this 5 and 8, add this 6 and 7. So 5 and 8 also yield 8, 13, and 7 and 8 also yields 13. So this is the one we can say, that is, we can say the corresponding, if you add the corresponding terms, it will yield the last plus first term, addition of last plus the first term. Okay, clear? Now, so we can say Sn equals last term, okay, this and this corresponding terms and this corresponding. So how many terms I will be adding? There are total 4 terms are there, so that means I will add how many corresponding terms we have. Before doing this one, I can go for total corresponding terms. So we have total corresponding term, total corresponding terms. So if n equal to 4, what is the total corresponding 4? Because each one we are making a pair, that is corresponding terms will be 2, right? That is, we can say in general, we can say n by 2. So therefore the formula Sn equals this formula, this Sn. Okay, this Sn will become n times of a plus L divided by L, right? A plus L divided by. Now check for 5 plus 6 plus 7 plus 8. We can get Sn equals, number of terms is 4 times of first term plus last term divided by 2, which equals 4 plus 8 is 13. 13 times of 4, this comes is 26. Clear? Now we got that formula for this one. Understand, guys? Clear? So this is how we have derived the sum of series if the series does not start from 1. Clear? Go back to the video and check again, so you will be understanding this one. Clear? Very easy. See you guys. Have a great day.